Hi, I'm Daniel, the founder of diybookscanner.org, and I want to tell you a little bit about this new scanner, starting with sort of important technical details. So the first thing you need to know is that this scanner is designed for books which are smaller than 12 by 9 by 3 inches thick, which happens to be the vast majority of all books, but it won't work for extremely large sizes, newspapers, oversized stuff. 12 by 9 by 3, which ends up being something like 90+% of all books. The second thing to know about the scanner is that it's very low cost. The design is such that you take one sheet of plywood and feed it into a computer-controlled cutting machine called a CNC router, and you get almost every part of the scanner back out. One sheet of plywood equals one scanner. A third thing is that it's a fairly unusual design in terms of the way it handles the book, and that's for a very specific reason. So, to give you an idea, you press on this lever to raise the book, and the book comes up to the glass and presses flat against it. And in almost all DIY scanner designs to date, the book remains still and the platen comes down to meet it. But the reason for doing it this way is because if you put a paperback book in here which wants to stay closed, when you pull the platen away, the book will close and you can lose your page. And the design of this scanner is such that this whole top piece can be removed, flipped over, and the bottom of the glass V becomes a roof where you can lay your paperback book and scan at a high rate of speed. So a little more information about this scanner. One of the great things that I'm testing in this design is this bike brake camera trigger. So instead of using firmware hacks or solder together things or special triggers, we want to use any camera. And one great way to do that is just to press the button on the camera. So as I'll show later in the video, up here I have a little finger that is pulled by this lever, and it simply touches the button of the camera to take a picture. That means any camera will work, any brand, any type, any firmware, as long as it has a button, we can use it, which I think is important. Now another thing that I've gone and done in this design is worked hard on making things easy on the book and on the operator. So the first thing I wanted to fix was loading a book, because it's the first thing you do when you scan a book. So I'm going to take off these bungee cords on the left and right, and in a commercial scanner you typically have to kind of get the book into the machine, and you have to raise the platen, lock it in place, and kind of feed the book in, and this is a really difficult thing to do. And on certain machines, this bottom area is blocked, and so as an operator, you can be subjected to substantial strain. And so in this design, I made it such that the cradle just comes out. And right now I have some accessories on this cradle. But the basic idea is that the book drops in here, you adjust left and right to fit the thickness of the spine, and then simply drop it back in the scanner. And right there, you're saving the operator a lot of strain. Now, the second thing is, if I try to lift this book right now, it's effectively at the end of a very long lever, and it's a lot of force. It's very hard on the operator's hands. I have wrist injuries, and I don't want to aggravate them doing this 1,000 times. So along the sides of the scanner, here and here, I have bungee cords to counterbalance the weight of the book. And since all books are different weights, we need a means of adjustment. Like, this isn't bad, I could do this most of the day. But if the book is heavy, it's possible to simply take one bungee cord and double it up for twice the lifting power. So whereas before the book was heavy to lift, now it floats almost neutrally. I'm putting almost no force on this handle. Again, to capture the book, in the past we've used special hacked firmware, different kinds of triggering mechanisms. Some people have tethered their cameras to their computers. I don't like getting a computer involved for a couple reasons. One is that in places where there's no power, or disaster situations, or environments where you can't plug into the wall, you don't want to be tied to a computer. And the other reason that tethering the camera to the computer is a bad idea is that only some cameras are supported. So, in using a mechanical triggering mechanism, we can absolutely use every camera that ever had a button. So operation is basically like this. Turn a page, pull up, press the trigger. keep going like this. With each press of the shutter button, you're getting 2 pages. At a good clip, you can capture about 1,000 pages an hour this way. The 1,000 pages an hour rate is what I like to call the no bathroom breaks rate. If you're like me and you like to check your phone or mess around, you'll get anywhere from a few hundred to 800 or 900 without much trouble. 1,000 pages an hour is well practiced and really moving. Now another thing that we've done on this model that's not completely fleshed out, remember this is a beta, it's absolutely not a final product and it needs development from the community, is the ability to scan paperbacks. Now you might say, well, all book scanners should be able to scan paperbacks, right? But the dirty secret of book scanners is that when the platen lifts up, the book here in the cradle wants to close because the binding of a paperback is very tight. And in this model, if the paperback were lifted up against the glass and it weren't open, it would be sort of disastrous. So the design of the scanner is such that there are these 2 or 4 clasps all the way around, and the top of it actually comes off, I'm not going to do it, and can be flipped over so that the bottom point of the 2 glass plates becomes a roof. And you can take the book and spread it open onto the platen like this, with the whole thing upside down, and scan paperbacks very quickly, which is something that no other scanner can do. And another thing, although it's not totally finished yet, is that the glass will be held in by 2 little clamps right here. And that means that you can actually pull the glass out so that there's a gap for a spiral-bound notebook, which is one of the things that's extraordinarily difficult to scan. They don't sheet feed well, they don't work in these kind of scanners because it bangs against the bottom of the glass, so on and so forth. So of course, in general, I designed this thing in 3 parts. So there's sort of the lighting part, which is just resting up here. Depending on your demands for color quality, for fidelity, for cheapness, or power efficiency, you could choose LED, halogen, or fluorescent. The basic rule is there's nothing better than halogen or tungsten for color rendition and image quality. The second best is LED, which has a bit of a bumpy spectrum, but it's totally usable. The worst is fluorescent. I don't ever recommend using fluorescent of any kind, even the so-called photo fluorescents. Moving down from that, we have the capture module, so lighting module, capture module, book module. The capture module simply has 2 cameras. I only have one mounted because I'm videoing with the other. Some kind of trigger mechanism, 3 possible trigger mechanisms. There's a shutter release from the manufacturer, there's a remote control, or there's the mechanical bike brake method, which is what I'll be using. And this portion of the scanner also contains the glass and becomes the paperback scanner when flipped over. And the bottom part is the book handling module, which accommodates the left-right motion of the book as it is scanned, and also helps the book self-center in the glass of the platen. One of the really important things about this scanner, in my mind, is that it's all made very carefully. So, for example, all the linear motion is supplied by skateboard bearings. And the reason for that is because skateboard bearings are available worldwide, they cost almost nothing, and they're incredibly durable. And if you're going to send a scanner like this into a place like Haiti, or even into somebody's basement, you want it to be easily repairable and easily understandable. Likewise with the bike parts. This is a bike seat post from a children's bike, and a dual bike brake lever from Amazon. If you want to look at the total material cost of this scanner, it's like, say, 30 bucks for the light, 40 bucks for the plywood, 20 bucks, 20 bucks, 20 bucks for skate bearings. It's not a great cost. And I don't know if I sell them what I will sell them for, but it's possible to manufacture this thing very cheaply. And because it's built on computer-controlled equipment, it can be sent out to anyone who has that equipment, and there are thousands and thousands and thousands of those computer-controlled cutting machines in the United States. So that's the scanner in a nutshell. I'm going to try and get some close-up shots of things working so you can get an idea of how the mechanics are going. Thanks. Well, maybe I'll just take this off the tripod. So I apologize for the lack of production polish on this video, but I really don't have a choice because this was my workshop, but I had to move out of here in a hurry as I'm switching jobs. So the lift mechanism is a 4-bar linkage. You're out here on the end of a lever. pulling up, and you can see the bungee cord counterbalancing the book. You can see the book when it comes up will self-center and flatten out beautifully. Towards the sides of any thick book, all V-shaped platen scanners go a little bit off-center, and I can show some photographs of that in the forum. That's something that we all need to work on, engineering something better, but it's a problem inherent to all of them. Here you can see the shutter mechanism, which is depressed by the bike brake lever. And all I do is simply press the button on the camera to capture. And so again, any camera will work. The distance from the camera to the glass is such that any Micro Four Thirds or compact camera, or in this case an APS-C Sony Nex-5, should be able to zoom in and capture the total area of the page. And at 12 by 9 by 3, it's possible to do easily 300 dpi across the page. If you get into the new 20 megapixel compacts, we could be doing up to 500 or 600. I haven't done the numbers, but things look really good. The cradle, as you saw, it's removable. It slides left and right very smoothly. But this is a specific limitation of this design, is because this is just free floating and has essentially no friction, the scanner must be on a level table or leveled. If it is unlevel, the book will slide to one side and make centering against the glass of the platen difficult. So one limitation, must be centered. Over here, I can show you the doubled up bungee cord. So again, all the counterbalancing for this mechanism is done with bungee cords, and you can adjust all the way to just neutral for the weight of this platform to neutral for the weight of a large book by doubling these up. And it's no more difficult than putting this from here to here. And now this is more difficult to lift. If I double it up, it will be less difficult. In all cases where there are bearings, which are here, 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 they're just skateboard bearings embedded in the wood. And wherever you see a bearing like this, there's also a bearing on the other side. So there are two bearings with a 5/16 bolt through them, or an 8mm bolt. I can't remember which I actually chose. But throughout the scanner, the design is that way, where essentially one portion has bearings and the other part has the bolt threaded into it. All the bolts in this design are straightforward, cheap, easy to find bolts, no funny size fasteners or anything else. I got all mine at Fastenal, and I will get all the part numbers online. There are a few, keeping in expectations in line, there are a few things that I would change about this scanner. Here's one. When you come down with the bike brake cable, it's possible to rub it against this part of the scanner. So something should be clearanced here. Another issue is that right now I don't have the metal clamps that hold the glass designed, or I haven't found the right ones, so this glass is just glued in place. Another thing is that with the bike brake system, the whole top module can't be taken off and turned over because there isn't a mount for this up here, and that's something I need to work on. Another thing is using the LED lighting as it is. This is the absolute correct distance from here to the apex of the platen, such that there's no glare, but I probably need to extend this up so that this can rest on a tabletop when this part of the system is rotated upside down. In general, I'm really happy with this scanner. It doesn't weigh very much, it doesn't cost very much, it's extremely high performance, and the optics are finally correct. So with the platen at 100 degrees, we have one of the narrowest platens available that is still optically correct. From the point of view of the camera, when there's a cover over the scanner, there's no glare from the light or from the facing page, which is the other source of glare. Of course, when you operate this scanner, you either need to operate it in the dark or have a piece of cloth draped over it. That's true of all scanners. They need to be shielded from sources of glare, like windows or overhead lights, which you can see very clearly here. No scanner can operate glare-free without a cover. So, those are some of the things that are missing, right? Somebody needs to design a cover or just drape a piece of cloth over.
The lighting could be analyzed further in depth. And most importantly, people could start playing with this thing. I've built in some things that are pretty neat. Like, for example, this whole piece of the scanner can be flipped this way for left-handed people. Some of the tricks like the glass adjusting out to accommodate the spiral binding of a notebook. A lot of these ideas are all here and waiting to be done, but they're not done in a sort of product-like way yet. The potential is there, everything's waiting, but it's just not quite refined because, frankly, this is the first complete version of this that I built. I built 14 revisions to get to this point, and then brought this one to New York and showed it. So now I'm really looking forward to working with the community, especially getting some people who have their own CNC machines to start building copies. The first copy is already out in the world. Ace Monster Toys in Oakland, California has got their wood parts, and they're going to start building it soon. And that's about it for this technical video. I'm sorry it's gone on so long. I hope you'll help me get one of these in every hackerspace in the US so that people can just go and use them. And thank you so much for your time and attention. Lots more on the way.